Howdy. That's sample number 2. Sample number 2. Gneiss. Same as number 1. And it includes hematite. That's why it is brownish in color. Nothing radioactive found. And here it says it's mainly made of quartz. We don't know the composition of it, since we don't know the numbers of those other pieces which got checked with this machine. And now, in my laboratory, that's the rock which has been at the Finnish Geological Institute. Which they say is kiilegnaissi. Kiilegnaissi on eräs yleinen gnaissin tyyppi. Gnaissin mineraalikoostumus ratkaisee, mitä lisämääreitä gnaissin nimen tulee. Gliitingnaissi on rakenteeltaan hiukan liuskennäinen gnaissi. Sen tummista mineraaleista pääosa on biotiittia, eli tummakiilettä, jonka lisäksi mukana maa, sälppää, kvartsia ja muskoviittia. Näiden mineraalien suhteet voivat vaihtella paljonkin. Kiilegnaissin väri vaihtelee mineraalikoostumuksen mukaan harmasta mustaan. Yeah, I have probably to find something in English. I haven't found any about kiilegnais in English, but kiile means somehow shiny. Gneiss, metamorphic rock that has distinct banding, which is apparent in hand specimen or on a microscopic scale. Gneiss usually is distinguished from schist by its foliation and schistosity. Gneiss displays a well-developed foliation and poorly developed schistosity and cleavage. For the casual student, it is convenient to think of a gneiss as a rock with parallel, somewhat irregular banding which has little tendency to split along planes. In contrast, schist typically is composed of platy minerals with a parallel to subparallel geometric orientation that gives the rock tendency to split along planes. Banding is usually not present. Yeah, this doesn't really work. But anyway, the banding, you can see it here. Or here, the banding. But obviously, that's just a really small part of the whole rock. And one of those quartz crystals dropped there as I tried to grind this really smooth, which is really, really difficult because they just drop off. They're not really well fixed into the rest of the material. So this dropped off somewhat 2 millimeters. And I didn't do anything to it. I didn't try to grind it smoothly or something because I think it will break. And I maybe have to buy one of those. Or many of those glasses more because I just have one which is broken. But anyway. Let's have a look at some pictures. That's just the first one of that little rock, 2 millimeters in diameter. I haven't watched the pictures yet, so I don't know. There might be some which are not really usable for anything. But many are really interesting. with these patterns we have here all over the place. The thing is, I try to check out if there is any shocked quartz or not. And we have distinct features like here and here and here, which are perpendicular almost, or at least to some degree not aligned with the rest of it. Here is something as well, and also here, of course. Obvious. Yeah, that's obviously a video. And this is somehow zooming through the stone. If you know anyone who knows about these things and is willing to take a look at those pictures or even to take contact with me in order to find out the truth behind those, it would be really cool. That's a smaller piece which fell off. That's really small. That's half a millimeter or something. But really interesting in structure, even though it's so small. It's much smaller than the first one. And it has also these distinct features on it. Oh, like patterns, maybe. If someone would ask me, I would probably say that this, what we have here, could be metal. I don't know. It just looks, it has a metallic appearance. Really interesting. Yeah, and again, that's a smaller piece. Yeah, I just wanted to show you those pictures in the hope that probably there is someone watching who either knows about this much more than I do, or knows someone who knows about this much more than I do. And I think these are just really intriguing features what we have here. Besides the colors and all the other things which are going on here. Also this thing here in the background. Really interesting. And also this one here. Two triangles back to back. There must be some videos, I guess, somewhere. That's actually a video. There it was. Triangle. I missed. Yeah, it's not that clear. Actually, here you can see it in some sort. But it's really fascinating. Like also this feature here. Yeah, actually, I wanted to show you something still. And this, what are these things which are embedded? Those dark. What are they made of? And here also we have this kind of structure going on here. That's the wheel. Yeah, that's really intriguing. That's from an article I found, almost dropped from the chair. So that's a small piece. Actually, we can make it like that. No, like that. 3 centimeters. Doesn't look like anything special to many, I guess. Half a centimeter. 200 micrometers. And they have, of course, all kinds of equipments. But I would say there is this kind of similarity to this picture visible in the part or piece I have under the microscope. Hopefully it's still there and the cat didn't drop it to the floor. But anyway, that's the whole article. Scientific reports open. Shocked quartz in distal ejector from the Rees impact event Germany found at 100 kilometers distance near Bernardzell, eastern Switzerland. Yeah, I was really surprised that there was Switzerland. Impact cratering is a ubiquitous process throughout the solar system, although its effects are obscured and or removed on Earth due to its active geological nature. During the formation of an impact crater, fractured, crushed, melted, and vaporized rocks and minerals are excavated from the opening transient cavity, forming an ejecta layer that thins away with increasing distance from the crater. And reference terrain. The distribution of ejecta around the impact crater varies and is dependent on various factors including impact angle, impact velocity, volatile content, cohesiveness, and composition of target rocks as well as the size of the impactor. Ejecta layers known on Earth are described as either proximal or distal. The division between the two is either made on the basis that proximal ejecta occurs at less than 5 crater radii from the center of the crater, and ejecta outside of that limit is then considered to be distal. Or distal ejecta are defined as ejecta occurring outside of the continuous ejecta blanket, which extends 2 to 3 crater radii from the center of the crater. So they need an impactor. Impact ejecta can be identified and characterized based on e.g. the presence of shock metamorphic features. In fact, the occurrence of shocked quartz in creatures' Pleiogene boundary layers around the world was key evidence for understanding that ejected material from the Jinxclop impact had spread across Earth. Shocked quartz is characterized by the presence of planar deformation features PDFs. They consist in thin, straight planar lamellae of amorphous or high dislocation density material, forming sets of features spaced 2 to 10 micrometers apart, orientated along rational crystallographic orientations, e.g. refs 1 and 10. There is only one diagnostic macroscopic indicator for shocked metamorphism, namely shatter cones. There are micro to mesoscopic pervasive curved to curvilinear fractures decorated with more or less divergent striations to radiate from an apex or an apical area, e.g. ref and reference terrain. Curved or curved linear features. I think we have plenty of those. Let's have a quick look at the video once again. Curved or curved linear features. I guess we have these. And also the PDFs of feather-like structures. Yeah, that's really interesting. But I leave it here. Really long video. Thanks for watching if there's anyone who has been to the end here. I really appreciate it. Thanks. Bye.